Guys, welcome back to TechDose, and in this video we will look at find longest special substring that occurs thrice 1 and 2 problem. These both problems are same, only they vary in terms of constraint. So we will be solving both of these problems with the most optimal solution. Let's now look at the problem statement. In this problem you are given string S that consists of lowercase English letters. A string is called special if it is made up of only a single character. For example, the string ABC is not special, whereas the strings DDD, ZZ and F are all special. Return the length of the longest special substring of S which occurs at least thrice, or -1 if no special substring occurs at least thrice. A substring is a contiguous non-empty sequence of characters within a string. Now, before looking at any example, let's look at the constraint. In this problem, the first part of the problem is mentioning the constraint length of less than equals to only 50. So even if you solve it with an n-square algorithm or any kind of brute force approach, it will be solved. But if you look at the second part of this problem, this problem statement is exactly the same, but they vary only in terms of the constraint. Here the length of the string can be 5 times 10 to the power of 5, so definitely an n-square algorithm is not a way to go. Now let's look at an example for better understanding. In this example, let's say we are given a string AA triple B AA. Our goal is to return the longest substring which occurs at least 3 times. Now if you look at this particular string, if I tell you about let's say how many substrings are present which contains only A. So there are 4 substrings. You have A, and this at 5 and at 6, right? So 4 times we have substring A. If I ask you about how many times this AA is occurring. So if I find out the substrings of AA, you have at 0, 1 and 5, 6. So it is occurring 2 times. If I ask you about how many times B is occurring, it is occurring 3 times at 2, 3 and 4. So B is occurring 3 times. If I ask you about BB, then BB is occurring at 2, 3 and at 3, 4. Right? We can have overlap, but if there is at least one character uncommon, then we are fine. We can take them as 2 different substring. So 2, 3 and 3, 4 are 2 different substring. So yes, BB is occurring 2 times. And if I ask you about triple B, then triple B is occurring only 1 time. So these are all the combination of substring which can be considered to be special. Now out of all these special substring, the constraint mentions that we need to return the longest substring which occurs at least 3 times. So which are the substrings which occurs at least 3 times? It is A, which is occurring 4 times, and this B which is occurring 3 times, right? All the rest of them are occurring less than 3 times, so they will not be the candidate. Out of these 2 options, A and B, which one is longest? So you see that both of them are of length 1. So you can pick any one of them and you will get the answer. Therefore, out of the candidates A and B, the longest length is length 1, so the answer is 1. Now you can go with the simple approach of creating all possible substring, and if the string length is n, then all possible substring will be equals to all possible subarrays in a given array, so that is order of n square. And then you can find out the frequency of each of the substring, right? So this order of n square will pass in the first solution, but it will not pass in the second part of the problem. I hope this makes sense. Now let's look at another example. If you have, let's say, AB, ABC. In this case, substring A is occurring 2 times, substring B is occurring 2 times, and C is occurring 1 time. And there is no other special substring. Out of all these special substrings, which one is occurring at least 3 times? None of them. Therefore, the answer in this case will be -1. Okay, I hope you have understood the problem statement. Now, let's look at how to count the longest special string. Now, let's say that our given string is from 0 to 5, that means of length 6. So if I ask you how many special substrings are there which contains A, only A, right? So there are 6 special substrings which is at 0, 1, 2, 3, 4, 5. So A is occurring 6 times. If I ask you about AA, then AA will be occurring 5 times. 0, 1, 1, 2, 2, 3, 3, 4 and 4, 5, right? I said that you can have overlaps, but at least you should have one uncommon character from different position, right? So AA is occurring 5 times. Similarly, you will calculate AAA will be occurring 4 times from 0 to 2, 1 to 3, 2 to 4 and 3 to 5. And you calculate how many times 4 A's are occurring from 0 to 3, then from 1 to 4 and then from 2 to 5. and 5 A's will be occurring only 2 times, 0 to 4 and 1 to 5. And similarly, all the A's, that means 6 A's, will be occurring only one time. Out of all these special string, how many of them are occurring greater than equals to 3 times? So they will become the candidate to be selected for the longest special string, right? So in this case, 4 options are available with us, and out of this you have to select the one with the longest length, and the longest length is of length 4. Therefore the answer in this case will be 4, okay, which is 4 A's. So I hope you have understood why did I select 4 as an answer. Greedily we have to pick the maximum length which has frequency greater than equals to 3, right? So those will become the candidates. Out of all the candidates, picks the one with the maximum length. Let's say we have another example, S2 equals to AA. Now in this case, A is occurring 2 times and AA is occurring only 1 time. So out of the 2 special string, A and AA, A is occurring 2 times, AA is occurring 1 time. So there is no substring which is occurring greater than equals to 3 times, and therefore you have -1 as an answer in this case, right? So if all the characters are same, that means if you have a special string and if the length of the special string happens to be greater than 2, then length -2 is also a candidate if you do not consider the other substrings present elsewhere. Like if you had all A's here which is of length 6, then 6 minus 2, that means 4 will be the most viable option. So I hope you have understood for just one special string. But what if you have multiple special strings? Like if you have a long string as it is given, you can note that for A we have 4 special string present at different locations, right? 4 special strings. So out of this, if I ask you about the first substring of A, what is the size? It is of size 5. Second run of A, it is of size 3. Third run of A, size 1, and the fourth run of A, size 4. Okay. Now I have to find the special string, and these are 4 candidates to be special string, yes, but then my goal is to find the longest special string. So if I just consider this A and find out what will be the longest special string contribution by A, then it will always be very obvious that I pick the one with the longest length, isn't it? So that I can increase the length of the LSS that we are trying to find, longest special string. So here this is of length 5, this is of length 3, 1 and 4. So it is better that I take the top options available with us, right? So let's see how many substrings can I make with this 5 ways. With this 5 ways you can make 5 different length of substring. You can have 1 length substring, you can have 2 length substring, 3 length substring, 4 length substring, 5 length substring as well, right? So substrings in this string of length 5 will be 1 length, 2 length, 3 length, 4 length, 5 length. Similarly, if you consider substring of length 4, you will have again 1 to 4 length as options, and that is what I have written here. Now if you are wondering about why I have enumerated all these values, then these are all the special substrings which can be formed from a given string. Like if you take a given string of length let's say 3, I can form A, double A and triple A, right? So this is of length 1, this is of length 2 and this is of length 3. So that is what I am writing, that with a string length of 3, special string length of 3, I can get special string length of 1, 2 and 3. How this will be helpful is, from this knowledge I know that I can have a special string of length 5 if I include all these 5 characters, right? Then I can have a special string of length 4 if I don't include either the first or the last character, right? If I leave the first character, I will have the rest of them, and which will be of length 4, or I leave the last character and I can have from first to the second last. And if you look at the last substring with 4 A's, I can have 4 length special string as well, which is all the A's, right? So if I want to maximize the size of the special string, I mean, by the way, all these are special strings. Whatever I have mentioned, 1, 2, 3, 4, 5 lengths, all these are special string. Why? Because in these strings, all the characters are A's only, right? So that is why they are special. So out of all these special strings, if you have to say what is the length of the substring which is occurring greater than equals to 3 times and must be of the longest length, then you can say that if there are 3 substring which is 4 A's, let's say, then you have another substring with 5 A's and another substring with 4 A's, then can you not say that in this case length will be, the max length will be equals to 4. Because of 4 length substring is present here, 4 length substring can be extracted out of the 5 length substring, and 4 length substring is present here as well. So out of all these available options, which are the special string containing only A's, out of this I will be picking the top 3 frequencies. The top 3 frequencies, or you can say the top 3 sizes. And out of these top 3 sizes, I will always pick the minimum value. Why the minimum value? Why not the maximum value? I mean, why not 5? 5 cannot be picked because if you pick a 5 length, then here it is occurring one time. But where else are you getting? Can you make a 5 length special string of A here? No, this is not possible because there are only 4 characters, right? Can you make a 5 length substring here out of 4 characters? No, it will not be possible because there are only 4 characters. So it is always possible to get a smaller length special string out of a larger special string, but it is not possible to get a larger special string out of a smaller special string, right? So that is the reason why out of these top 3 options we will be picking the minimum one. So out of 5, 4, 4, 4 is the minimum, right? So in this case, if you consider only A's, then the longest special string contribution, LSS, contribution by A will be 4. But then A may not only be the character which is present in our string. If you look at the problem statement, we can have characters from A to Z. So from A, the longest special string that I can form is of length 4. So don't you think that I will have to repeat it for B, C, D and so on till Z? Yes, I will have to repeat this same operation again and again, right? So for B, I will be repeating the same thing. If you repeat for B, then you will find that the first substring, I mean the special string of B, length is 3, second one length is 4, and the third one length is 1, and you have a fourth one as well with the length of 2. 3, 4, 1, 2. So check this out. We have 3, 4, 1, 2. Now if you sort it again, then you get 4, 3, 2, 1. Out of this, just enumerate the first 3. I mean, you can enumerate all of them simply, right? It does not even matter. You do not even require to sort these options. So if you enumerate, then for 4, if there are 4 B's together, then I can, out of this special string of length 4, I can get a special string of length 1, 2, 3 or 4. How? I can just include the first character and get a special string of length 1. I can include first 2 characters and get a special string of length 2. First 3 characters will give me special string of length 3. And the first 4 characters, that means everything, will give me a special string of length 4. According to the previous explanation of what we had seen, out of all these options, I will be picking the top 3. Why I am picking the top 3? Again, I am repeating that we have to find the longest substring which occurs at least 3 times, isn't it? So in this case, length 3, 3 and 4 are satisfying the criteria. So out of this, the minimum is 3, and therefore LSS, when you just consider B, it is giving me 3 as an answer. You cannot have a length more than 3. Because if you take a length 3, then you will have one substring here, another substring, this one, and the third substring here. You cannot have anywhere else. If you increase the length to 4, you will just have one substring. You cannot have any other substring, right? So there are 2 criteria. The first criteria is it should be a special string. That means all the characters must be same. And the second thing is you need to decide on a length which is present minimum 3 times. Following these 2 criteria, you have to maximize the length. Okay. So I hope our idea is clear, right? Now based on this idea, let's try to do a dry run, and we will just be maintaining the top 3 frequencies because I know that the top 3 frequency will be the one which will be giving me the longest length, not anybody else, right? So let's do that. Let's say that our current pointer will be starting at index 0. Okay. And I will always be maintaining the last seen character. Initially, I will be giving a star. I mean, star is not present in the input altogether, but I'll be taking a star saying that I have not seen anything. And I will be maintaining the window length. This window length will say what is the current length of the special string. Okay, that means if you say A's, then it will find out what is the window length of all A's present together. This is called a special string of A, right? And I will be trying to maximize the length after doing all the operations. So in this case, I am taking a simple example where I just have A and B in the input, not A to Z. Okay. Now I will be starting my operation with index 0. So this is for maintaining the top 3 frequencies. So this is a simple array where it will be of size 26 from A to Z, but here I have taken just for A and B, and the top 3 frequencies will be maintained. So let's start our dry run. You will always be checking if the current is actually equals to the last seen character. If it is equals to the last seen character, then the window length will be just increased by 1. That means we are extending the special string. Otherwise, if the current character is not equals to the last character that we had seen, that means we are starting a new special string. Okay, and in that case my window length will restart counting from 1. Okay, so the window length is 1 here. Now if this is 1, then I will be filling all these values, the top 3 frequencies, with value -1. Okay, because I want to maintain the top 3 frequencies, so I will be just initializing the minimum value possible. In this case, value less than 0 in length is not possible, so I have just assigned it with -1. You can assign it with any negative number. Now I will be checking. I was doing it for A, right? So I'll be going to A and I will be finding the minimum value here. So the minimum value, all of them are same value, so you can take any one as the minimum value. So let's say the first one is the minimum value. This will be checked with 1. If the currently recorded window length is larger than the minimum, then I can replace this value and overwrite it. And yes, it will be overwritten. But then how will I know which location to overwrite to? So I will be using the reference. Okay, instead of maintaining the index, I will be maintaining the reference and I will be overwriting the value. You will look at this in the code. Now if I have to move this current pointer forward, then I will have to update the last scene. Okay, so the last scene will become A and then we will be updating the current to the right hand side. In this case, you check that it is the same as the last scene character. So I will be just doing +1 to my window length and this will become 2. Now since this is 2, again we have to check our A. In the A, I will be maintaining the top 3 frequencies, right? In this case, I have top 3 frequencies 1 -1 -1. So let's say I will be finding out the minimum value, and let's say this -1 is coming out as the minimum value. Now I'll be comparing with 2. Now since 2 is larger than this -1, so I will be just overwriting this to 2. And after having done this, I will be recording my last seen character. It is the same, so nothing will be done, and I will be moving to B. When I am present at B, then this is not equals to the last seen character. So the last seen character will be overwritten and this window length will restart counting from 1. In this case, this is B. So I'll be going to B. I'll find out the minimum value out of these 3. Let's say you are finding at 1 0. This is the minimum value. I'll see that 1 is greater than -1. So I will be overwriting this to 1. Okay. So at this point, we have all the 3 values as 1, 2, -1. And you have 1, -1 and -1. So this is for A and this is for B. Index number 0, index number 1, right? And these are the top 3 frequencies. So this is the current status. Now I will be moving to the next character, which is B. Now this B is the same as the last seen character. So it is fine. I will just be increasing the window length by 1. And since this is B, I will be going to B and finding out the minimum value. Let's say -1 is the minimum value. 2 is greater than -1. So I'll be updating this by 2. Okay, and we are done. Now I will be updating my last scene, but since it is the same, so I will still have B. I'll be going to A. Now this A and B are not the same, so I'll be overwriting my last scene character to A and my window length will restart from 1. Now I'll be going to A and finding in the top 3 frequencies which is the minimum. -1 is the minimum, so I'll be comparing with the minimum, and since this one is larger, I'll be updating this. If you are wondering about why I am always taking the minimum and why not maximum, then you should know that if you want to be in the top 3, then it is always good that you fight with the weakest person, because the chance of you defeating the weakest person will be the highest. If you cannot defeat the weakest person, then how will you defeat the strongest person, right? So you may be the top 3, but if you fight with the strongest person, you may lose. So it's better that you fight with the weakest person and decide whether you be in the top 3. Using that logic, we will always be comparing with the minimum value out of the top 3. Okay, so I hope now it should be clear. Now I'll be moving on forward, and I'm seeing another A which is the same as the last scene, so this will become window ++. Now again I will be going to this A, find the minimum value. Let's say it is 1 and this is 2, so 2 is larger, so this will be overwritten to 2. Again I'll go to the next character. It is same as A, so I'll do window ++. and then I'll be checking the minimum value in A. So this is 1. Now 3 is larger, so 3 will be overwriting this value, right? Now I'll be going to the next character. This is B, not equals to the last scene. So the last scene will become B, and the window length will restart counting from 1. Okay. Now I'll be going to this B, finding the minimum value. It is -1, and so I will be updating this to 1, right? And again I'll be going to the next character B. It is the same as the last scene, so I'll do window length plus 2, and then I'll be going to B and find out the minimum value of 1 to 1. Let's say it is 1, and so it will be updated to 2. Fine. Now I'll go to the next character A. It is not the same as B, so it will be overwritten. Window length will start counting from 1. Now I'll go to A, find the minimum value. It is, let's say, 2. Now this 1 is less than 2, so nothing is going to happen. When we go to B, it is not the same as the previous character, so this will be overwriting and my window length will restart counting from 1. So we will go to B, find out the minimum value of 2 to 1. It will be 1. But this one is not larger, so no update is going to happen. Again, we will go to A. Okay. So when we are at A, again, it is not same as the last scene. So I will be updating this and it will become A. My window length counter will restart from 1. And now I will find the minimum frequency in this A. Out of 2, 2, 3, 2 is the minimum frequency, but 1 is smaller, so nothing is going to happen. If you go to the next A, it is the same as the last scene character, so I'll do window plus. Again, find the minimum out of all the A's top 3 frequencies. It will be 2. This 2 is the same, so no change. If you go to the next A, then it is the same as the last scene character, so you will do window plus. So it will be 3. Now out of the top 3 options, this 2 is the smallest and then 3 is larger, so this will be updated to 3. Okay. After this update, we will be going to the next character and we are done. When we are done parsing the entire string, then we will be checking character by character all the top 3 options. Let's say in A, we have options of length 3, 2 and 3. Out of these 3 options, we have already discussed that if you have 3 A's, then 2 A's and then 3 A's, then what will be the longest special string? All of these are special, right? The longest special string will be the minimum length, which is 2. Because if you take length 3, you will not be having 3 frequency. Okay. So the LSS contribution by A, longest special string, is of length 2. Now let's see the contribution by B. It is having 2 to 1 as an option. So out of this, what is the minimum? Minimum is 1. Therefore the LSS with B is giving me 1 as an answer, right? So out of all these contributions of A and B, which one is giving me the maximum? You have to maximize all these minimum values. So what I am doing is I am finding the minimum of all the top 3 options and trying to maximize this length. So maximum of 2, 1 will be 2. So that's why the maximum length will be 2, and this is the result. So I hope you were able to understand it. Now in this case, we have done only a single time parsing of the entire string, which is order of n. And in order to find the minimum out of the top 3 options, it is order of 1, and overwriting is also order of 1. Therefore the time complexity is order of n. And the space complexity can be considered to be order of 1 because we will be maintaining all the rows from A to Z, which will be 26 rows, and each of them will have only 3 entries, which is for maintaining the top 3 frequency, right? So that is why the total entries will be 26 times 3, and all of them are integer type, which is 4 bytes, right? So this is a constant, and that is why the space complexity is order of 1. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, I have written an API for getting the minimum value out of the 3 values A, B and C, and this is sending the reference instead of just sending the value. By using the reference, we can override the value directly without thinking about which index it is present at, right? This maximum length is the main function where we are getting the string, finding the size of the string and storing in n. And this is the vector of vector, which is the top 3 frequency, 26 number of rows and 3 number of columns for the top 3 values of each of the character, and initialized with -1 initially. Now I'll be finding the top 3 substring, that means the special string of each character from A to Z. So as I had explained in the dry run, my last scene will start at star, that means I have not seen anything, and my window length will start at 0. This loop will run for each of the character one by one. So whenever I reach to a character, let's say C, then it will be subtracted from the base of the number system just to find the index. So for A the index has to be 0, for B the index will be 1, and similarly for Z the index will be 25. So this is for that adjustment. We are finding index. Now we will be finding out what will be the window length. So if the current character is the same as the last seen character, then my window length will increase by 1. Otherwise, if the current character is a new one, then a new special string is starting at this current point, and so the counting has to start with 1. Okay. Now whatever is the case, I will update the last scene to my current character, and then I will be finding the minimum of all the top 3 options. Like let's say I was looking at B. Then for B, what are the values that have been filled? Out of these values, I will be taking the minimum and take the reference of this, that means the address. And if the current window length is greater than the minimum that is stored at that address, then I will be overwriting this value with the window length. And this will be repeated for all the characters in the string. And once we are done with this, then for every characters, let's say for A, B, C and so on till Z, each of them will have certain minimum value. Let's say for A the minimum value was 3, for B the minimum value was 1, for C the minimum value was 2, and similarly for Z it was 4. Then out of these all these minimum values, what are these minimum values of the top 3? This is actually the LSS, that means the longest special string if you consider A. Now this one is the longest special string if you consider B. Now out of all these longest special string, I have a choice to choose any character. I can go with any character where I can get the maximum value. So I'll be trying to maximize the value by iterating through all these characters and check each of the minimum of the top 3 values, right? Which one will give me the maximum? 4 will give me the maximum, therefore 4 will be the answer. So what I am doing here is taking maximum length equals -1, and out of all the LSS contribution, I'll be finding the minimum value of the top 3 for each of the character, and I'll be trying to maximize it. So this will be my final result, and I hope you were able to understand it. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.